And with that, I think we're live and broadcasting, which is actually pretty cool. Um, so, the idea of our conversation is to talk about what it means to be a data professional and the things that we have to deal with and go through on a day to day basis. Um, I appreciate you being willing to kind of make this journey with me. I know we talked behind the scenes about like setting up a fake project that we were working on and then kind of walking our way through what it takes to kind of live through like a data centric project and the different considerations we have. Both of us have a very strong healthcare background. And so we decided we would do the premise of what if we had a business owner come to us and say, I would like to take some of that really neat AI technology and make it so that our researchers, healthcare researchers, can do real world evidence research by being able to, in human language, say what research data set they want. And the system would just magically figure it out and give them all the right data to do their research with. Is that what we were thinking in terms of defining the problem?
That will certainly uh, create an interesting problem to discuss. Yeah, I'm not sure because that's uh, a that is not a solved problem. That is
Yeah.
a that is a good way to discuss the limitations and uh, the different kinds of challenges that exist in algorithmically generating that capability.
Yeah, I liked it because so many people today think that AI is just going to fix everything and
Right.
that it could do everything. Like, oh, well, it can reason now. So it should be able to just, and like it's the magic bullet of all things. And I think it would be neat to talk about that kind of request because it feels very realistic to me.
Yeah.
It seems like the types of things that, I
That
get
we're on the
hit
verge
with.
of.
Yeah, the different people in the business are going to start like just thinking that you could point an AI system at something and it's going to be magical and figure out all the problems and it'll just solve it and there's absolutely no issues. And
Yeah.
yeah,
Yeah. And,
we're definitely not
and
there.
it's deceiving because, I can go to uh, any of the really robust large language models that are out there and say, give me a query that uh, provides this kind of cohort uh, for an epic system or clarity and it will spit out some code that will, kind of point in the right direction. Um, it'll have convincing sounding table names and uh, there will be codes involved, so uh, it'll definitely create something that if you didn't have to actually run the code, you'd be pretty convinced, like, oh yeah, there it is. Somebody could say, oh well, I just asked, you know I just asked for what I wanted and they gave me this should work, right? And
Right.
uh, the and it would, if you actually tried to use the code, it sends you down a rabbit hole of discovery that, of course, anyone who's a programmer in the healthcare industry has been down that road of like, oh, well, that code actually means this in this context, and you can't use it in the kind of context you're talking about. So, and it's only relevant if this procedure was performed because of this kind of diagnosis. Even though it's the same procedure, you have to have the diagnosis code in there because it could also be this other possible diagnosis. And so if we're trying to build a cohort, we have to know what the entire framework is. And so the complexities of research are not going to be addressed because there's just not enough publicly available code to really do that. There's a lot out there, but and it could give you a general hint as the direction you might want to go, but you're going to have to explore both the clinical side and the technological side of whatever system you're in.
Right. And I think that's a valuable thing to talk about is why is this hard, in terms of healthcare data? I know throughout my career working in healthcare data, we'd have people coming from outside, industries, in early data warehouse days and whatever. They'd go hire somebody from the finance industry who didn't realize that healthcare data works so differently than other industry data. And they'd be, you'd have this new boss that would show up and then, they'd be like, well, you have to be a bunch of idiots. Why can't you build a data warehouse that works for people? Like, what the heck's wrong with you? And, why are all these reports wrong? And why is this so hard? And why does it take so long to develop things? And you must be just stupid, And it's like the data in healthcare doesn't work the same as the data in finance. There are so many reasons it's not the same. And trying to explain that to people is so hard,
Yeah, it is. And it's because the conceptual space for financial data is specific, and most of our systems are designed for that financial component, which doesn't lend itself to abstraction. It's actually lending itself to differentiation based on the economics of the work. But so it's going to ignore certain clinically relevant differentiation. So if somebody's having knee surgery, the surgeon might be in there for 6 hours or might be in there for 3 hours, but they'll get the same procedure. But it's actually a radically different clinical experience for the physician. And there's a whole bunch of clinically relevant details that they care about as a physician, but from a billing perspective and from an economic perspective, the billing system is just like knee surgery. They don't care.
Right.
And so you've got two different levels of abstraction and details, whereas the clinician will talk about clinically abstract concepts and use terminology that you might have to go through and work through a whole bunch of billing references to identify that same clinical abstraction. And a billing person would have a different kind of abstraction. And so tying billing systems into clinical systems involves trying to understand the abstractions of both of those systems and creating relationships between them. And that's a non-trivial problem.
It is. And I guess that would be like, for me, one of the big things that if somebody just like, hey, can we point a large language model at healthcare data? That would be like one of the first things that I think it would be important for somebody to understand as part of the problem is that it's pretty nebulous when you say healthcare data. And I know we tend to think, because we've worked in the industry, we tend to think of like plan data, insurance plan data, and then we think of the clinical data, and then we think of the healthcare billing data. And those are three very different things. The clinical data and the billing data seem to feel as if they have some connection to each other, but they don't always,
Right.
because
Yeah.
the physician, had to provide a number of services. And so you've got this very rich detail as that supports the point of care and keeps all of the information about what was going on. The difference, why was it a 3-hour surgery versus a 6-hour surgery? Like that richness is going to be found in the clinical data. But over on the billing side, you're just going to have a code for knee surgery.
Right.
It's very cleaned up, but it's cleaned up to the point of losing so much relevance.
Yeah. Yeah. And the trying to abstract out of clinical notes and clinical information the relevant concepts so that they can be utilized by researchers is in a very complex task, one that definitely large language models could help with.
Oh yeah.
But just as like a driving system, you're going to have some sort of tagging mechanism that gives it a starting point, that enables it to you have to give it some kind of way of abstracting. And once you've abstracted a certain amount, you can actually train language models or visual models or whatever you're using to then tag. But your initial step is going to be a manual one as you're training that data. So there's no magic. There's no shortcuts really.
Right.
To the initial training, right? Once you have it trained, then you can release that those neural nets onto your data, and it'll make sense of it. But the sense it's making of it is the conceptualized space that you've defined.
Right. I've been through that journey with natural language processing from, kind of early days where like people were trying to extract sentences and then parts of speech in order to get, and then, moving more towards using, large language models and AI to parse physicians' notes and that sort of information. And I definitely see that as a place that AI is really helpful when it comes to healthcare data, is parsing information out of those notes. But if going back to the original problem, if the business customer says to us, hey, I want an AI system that I can say, I'd like to study diabetics with, this condition who, whatever, like be able to write a statement and then it magically becomes some way of extracting the cohort that you want, that, okay, here's people who have had those experiences. We can now ask questions about, did treatment A or treatment B, what were the outcomes between those two populations or whatever. I think you can get to the place that you have access to more rich information by using the AI to get the information out of the notes versus trying to get AI to write directly against like an EMR system a way of going and finding the data for you and bringing it back. Do you know what I'm,
Yeah.
does that make sense to
Right.
you? Like those seems like two totally different problems. Parsing a physician's note seems like something that's definitely in scope for AI. Weeding through an electronic medical record system, I don't know that we're there yet.
Well, it's the parsing clinicians' clinical notes is possible if you know what you're looking for, right? And you can get some useful annotations and relationships from notes, if especially if those notes are separated. So like if you've got your lab notes, and so okay, I'm looking for lab information, you could then take lab descriptions, and you then have a good starting place because you can take those clinical terms that are fairly distinct, not perfectly distinct, but fairly distinct, and then you can train a model to try to identify context in which those labs may be referenced in the lab notes. And that can be helpful, but if you don't have that kind of context for your large language model, then you're the nature of the complexity generates more noise than it does. You're going to find all kinds of relationships that don't actually exist.
Those AI hallucinations. Garbage in,
Yeah,
garbage
well,
out.
if it's going to find what you tell it to find, because natural language is so flexible, and clinicians are
Lab
so.
notes were always my favorite because they were kind of the easiest to parse. They get generated by software, and so they're very straightforward. In terms of a lab note, like that's definitely trainable. Physician notes were a bit more difficult because they're like generated from each and every physician that kind of speaks differently. And they're also generated by a workflow.
Right.
So I definitely found them more difficult, but I've never applied a large language model to physician notes. So I wouldn't know exactly how that performs, but I would, given the work I've done with large language models, would suspect that it would do a fairly good job of being able to pull out contextual understanding. And a lot better than the stuff we used to do. Holy cow, having to like try and find rule out diagnosis that were in notes and all the stuff like patient has history of cancer 10 years ago. Okay, well now I have to impute a date. What's the date of the note? What is 10 years ago? What is the acceptable range, of uncertainty on a decade comment? Like all of that used to be very manual. And now like large language models could definitely help you with that. They can, you train them correctly. Right. They can say things like, there is evidence that the patient had cancer between 1992 and 1995 or something, right. Somewhere in that time period from the physician note. But for me, I think if I got approached by a business owner who said, why can't we just, with all this AI technology, why can't we say, I want to study this kind of cohort, and the machine just goes and figures out how to get the data. For me, I think there's two things that, experiences I've had with systems that I just wonder how AI could even overcome the issue. And the first one is probably one of the reasons that healthcare data is so different from everybody else's data. Like the finance industry, you've got a teller, like a bank teller who's entering transactions. They're incredibly standardized. Dollars are fungible. $1 is the same as another dollar. They're just, you're recording where they were and what, whatever. And the teller is generally your entry level position. They're like the factory worker on the floor. They're, kind of the most junior person who has people above them that are making decisions about how they do their work. You get trained. This is the steps. This is what you do. And so everybody kind of follows the same script. Healthcare is nothing like that. Healthcare, the person who's assembling your product is a physician, and people are not fungible. One person's not the same as the other person, so you have this highly skilled person who you are literally paying them for their individual expertise to put together the healthcare for you, an incredibly individual person. And so, like, how physicians record things in an EMR is literally different from one physician to the next physician. How they choose to implement the EMR in their office.
And how they, when they're taking notes, how they choose to talk about
it.
The same clinical experience. The terminology is fluid, and even physicians have to clarify when they're talking to each other. Oh, do you mean, this kind of diabetic or this kind of diabetic? What are we talking about when we're talking about, that condition? So the use of language, if you're in a engineering job, the terminology used is explicit and unique. So you have for the most part, a very one-to-one relationship with a concept and a structure. And so you're going to end up, there's groupings, like you can have nuts and bolts, and then you've got, but it's going to break down into very explicit, when you're dealing with data, a very explicit description that can't be confused with any other engineering object. And same thing in finance, right? All of the things that we're used to using data for have had a long history of data management and data, making sure that terminology is not confusing. And the practice of medicine has been much more philosophic in its approach.
Yes, and how it records evidence electronically.
Yeah.
Right. And it's also knowledge based, because like I've worked on data projects where you have a physician lead that's like, oh, this is where we record the data. This is where you need to get it from. This is what you're going to pull out. And then we like, oh, well, we don't have access to that table. We've got to get it added to the warehouse. Now we got to do this. So we like, and there's this like long journey. And at the end, basically, oh, that's how you record it. Apparently none of your other colleagues record that information there. So I've just been able to pull your information, you know?
Yeah.
Like,
yeah,
and rule out diagnosis is like as soon as somebody brings up like a rule out diagnosis, I, as a healthcare professional, have worked with this person and I have decided they are not this thing, right? They do not have
Right.
this disease. That can end up in notes. That can end up in a rule out diagnostic table. You can find actually negatives on problem lists because they'll stick them there, and I'm like, if you decided that they don't have this disease, why is it on their problem list? But yet, behold, you go and look at the data and where all these
Right.
different physicians are recording things. You'll find some
Yeah.
physicians that's how they want to use the problem list, is to say, stop thinking that this person might have this disease, because they don't. Right?
Yeah, and part of that is that physicians, their practice has historically not required the kind of structure that, if you go back 200 years for financial people, they had to have tables. They had to have a way of recording transactions that were data centric, and accounting is a data exercise. But a lot of physicians, that is not historically, and so as software evolved, right, it evolved to provide flexibility for the physicians who didn't wanted to just be able to kind of keep practicing the way they were used to doing it. And
Right.
so the software evolved to be customizable. But that's really difficult to manage from a data unification and secondary data creation perspective, because you kind of have to build lots of case statements to deal with the different ways that data can be stored.
And all the different places to even go look. I think that was always an interesting exercise for me, because working with staff around a concept or an idea, and then going out and talking about what are the different workflows and the different ways it gets recorded. So you could have the same activity and different physicians will record it in different places in the clinical EMR. I mean, once it hits billing, it's real standardized. But on the clinical side, if it's information that doesn't drive billing, then from one physician to the next, you could have real diversity in how they're having the system pull together the information that they want it to give them when they're working with patients. But then you multiply that, because then you have different workflows within the healthcare system that might actually record the same concept. So the example that keeps coming to mind for me is, recording that a patient has passed away. There's if it happens in the hospital and you're actually doing the morgue thing, there is a workflow for that. But it is not uncommon for a family member to call up a physician and say, hey, I wanted to let you know Dad passed away at the nursing home last night. He loved you being his doctor, but we need to cancel his appointments or whatever. That's a whole different set of information. It's not like you're tracking the healthcare system taking care of somebody who's passed, but now, so that might end up actually being a physician note, family member called and advised, kind of thing.
Right.
And so depending upon who talks to whom in the healthcare system, the information might end up in very radically different places. It might end up being tagged onto a cancellation note, or it might get tagged to a physician note, or it could get,
or even
depending upon who they're actually talking to when the information is understood.
Or the billing system makes a note.
Right.
We tried to collect, payment and the person's deceased.
And
So
the person's now deceased. Yeah.
yeah,
And so the individuals following the same workflow will record in different places in the clinical system.
right.
But then that goes back to that conversation about there's billing data, there's clinical data, there's, health plan data, there's, there's these different things. And the information might end up, depending upon whether you're talking to somebody who's scheduling your appointment or you're the medical provider in the hospital that's making the pronouncement of death, or depending upon who it is in the health system, there's not like a central place that, hey, I'm looking for, people who were taking this kind of treatment and, their survival rate in 6 months. There's no easy place to go and say, do we have evidence, that they were alive 6 months later? Because there's like 10 places to go, depending
Right.
upon how that information might have become available for the healthcare system.
Yeah.
And the
And
idea of that's one item. And people think I'm joking, but everything in healthcare is like this. Pick
right.
something else.
Yeah.
It gets
You're gonna
recorded 10 different ways in 10 different places, and
and
it's all
then
over the
if you
place.
try to bring it all together, you just end up with massive amounts of duplication, but seeming different records. But it's actually different ways of recording the same event, the same action.
Yes, which is the other part of the problem is did they have two different colds, or was it just a delay between this being recorded and that being recorded? Or is this a different event from that event? Because I see a record over here saying it happened 10 days ago, but then a record over here that indicates that it happened yesterday. Is that the same event or two different events that got recorded? And having to understand all that information so that you're able to go, okay, this is coming out of the physician note and it's saying the onset of this was 10 days ago, or it got recorded here and they backdated because that was when the onset was, but this is when the actual official code got added to their record. Or having to get that to line up is not easy stuff, right?
Right. Yeah, and it's super relevant from a clinical perspective. It's very different to say, oh, this person had to go back under for a second procedure, the same procedure twice, or to have just two records of the same procedure with different dates.
Right.
One is a really concerning clinical situation where something happened where they had to do the same procedure twice, and the other is just bad data,
Bad
right?
data.
Yeah, and and you can have really weird situations where things get recorded and it's the same procedure you'll see 6 or 7 times in a patient record when you're trying to join from different systems, or you'll see the medication from different in terms of the medication was ordered and then the medication was delivered, and if it's an inpatient situation, it might look like the patient got 3 times the amount of medication that they actually received.
Right. And it's
Because the dates don't align, or the
or whatever. Yeah.
date, uh, and trying to identify if the medication that was received was actually the same medication ordered can be really challenging because they use different codes for the pharmacy data than the clinical data, right? So the amount of effort that it takes to curate data across those systems is profound, and definitely AI can help. It can make some of those tasks of connecting the dots between systems easier, but you can't a hallucination event in that context could lead to really bad clinical assumptions, from a research perspective. You just cannot trust, if you're doing research, you cannot leave it to, kind of a black box algorithmic approach, because you have to be able to speak to the anomalies, and you're not going to know the anomalies if you're leaving it to strictly to a machine to
try and parse it out,
parse out the things that don't make sense, because it won't be able to differentiate.
Right. And I mean, you could go back and train and like add these things in, but in essence, that goes back to the business thinking it's a silver bullet that you're not going to be spending time getting it trained basically to learn a lot of things that people who work in either quality improvement, like clinical care improvement, or who worked in research, or, these are things that we've known for a long period of time that we have to do as part of the work that we do in order to do the work right. And I think you could train AI against a lot of that, but I think I don't know. I feel like it has to go from being a 2-year-old to being a grown-up, and it's not something that if the business came to me and said, can we just point AI at healthcare data and have magical discoveries about how to improve the life of people, like, it's not going to be that kind of silver bullet right now. We're not there yet. Right?
Well, yeah, I mean, even if you had an insane amount of compute and capabilities, you're dealing with a problem set that I think is probably more profound than the natural language compute, right? Because natural language, the nature of our large language models is that it's just producing a creative output, right? It's not. There are situations where it's producing. We have we have neural nets that are driving vehicles, right? That's a very different kind of problem set, and you do have to have absolute accuracy in that kind of context. But we see how difficult that is, right?
Mm-hmm.
We see how after a decade of investment, the Tesla self-driving still is not self-driving, right? It's still trying to train through its drivers, because the space of possible lethal decision making is too large, so they can't give it over to the machine learning algorithms, right? Because it'll kill people. So it's a similar problem. If we start publishing a research paper that says, oh, this procedure is really good, or this drug is shown to be effective, and we're not really verifying that, it could have lethal side effects. So I think the space has to be limited to problem sets that are non-lethal, right? So for my for my money, and it saves a lot of money, right? If rather than trying to do a $1 billion neural net to solve all of healthcare's language issues, if you just say I'm going to train a neural net to help me identify generic drugs as they relate to NDCs, so that I have a one-to-many relationship, which there'll always be a mini relationship to an NDC from like an RX norm,
Right.
right? So if you're using a neural net to kind of speed up the process of mapping those RX norms to NDCs, that seems like a very valuable use of a specialized neural net, because it's a highly specific set of tasks where it's either right or it's wrong. And then
Right.
you can have
Right.
clinical experts go through and say, yes, good, nope, that doesn't work. And you can use other algorithms to kind of adversarially reinforce, what's right and wrong through other data sets.
Mm-hmm.
And so you can kind of improve your neural net rapidly through known relationship mappings. And but that is an example of where, and you could do the same thing with clinician notes in terms of clinical drug terminology, right? Where you're trying to identify out of a clinical note about somebody's personal health record, where they say, oh yeah, I'm on I took some acetaminophen, and that gets put into their health note. So you can parse out, oh yeah, they're on these medications, they've taken these medications, and that's another kind of good use of a highly specialized neural net, where it's pulling out relevant information very quickly for a physician. So when the nurse is asking about medications, that it may flag, oh, they actually, there's a note here, they're allergic to that thing they just said they took. And
yeah, I think systems have gotten a lot better on that. I think the other place, now that you're talking about it, is we have, in terms of data collection, a lot of black holes. Where, and we talked about it earlier, a great black hole is you have all these clinical notes, and then you have a billing expert who's looking at what happened on the chart and putting in the billing codes, like I'm billing for this, I'm billing for this, I'm billing for that, right? But there's nothing, well, sometimes it depends on the software. Some EMR systems are different than others, but very often it's just a black hole. You have this whole big thing over here from the patient being in the hospital for 2 weeks, and then you've got these codes over here.
Right.
And because there was a human, or a process that made decisions about what got billed, like there's nothing really exists there that kind of says, oh, here's the complications that fed to this code being elevated to this type of code versus, I mean, it's just like, it's two different systems. Like you wouldn't even know that they were tied together between the clinical side and the billing side. And very often the EMR doesn't even record it. It doesn't record how they made that decision to go from here to there. And so when you're trying to get a holistic picture of a patient's care, like sometimes you have to stack the clinical record and the billing record And we were talking about that, like, did this happen twice or just once?
Well, and even
Some of it
even
comes
like
out of that because, like, I have the indicator here in the clinical, I have the indicator here in the billing. I have to remember that these are from the same encounter, even though, like, they just sit side by side with nothing tying them. And in order to
yeah.
have the full information, I had to stack them, but now I have to keep track. These are all together, right?
Yeah, and of course there's a human component in the billing codes that are chosen. You know, a lot of times physicians will say, "Oh, I did this procedure," and the biller will say, you know, the coder will say, "Oh, well, you know, that actually wouldn't even pay for half of, you know, wouldn't even pay for the anesthesiologist if I billed for that code. So I'm going to stack these 3 other codes that will actually pay for the procedure
Ugh.
uh, because that's what the insurance company's willing to pay for." And so that
Yeah, I
there,
think we'll get into trouble, like people thinking we have something to do with how healthcare gets built.
yeah, no,
I have nothing to do with the decisions that are made by coders in terms of how they code the clinical encounter appropriately so that they talk the right language with whatever insurance company or whoever's covering your bill. I'm just the downstream stream recipient of
of that
all of
data.
those decisions that I don't have
Yeah,
any insight into what was driving that decision, why that decision got made, why that code got there. You know, I'm sitting in the point where, you know, if we can't measure something, we can't improve it. So if
right.
we want, you know, I mean, as you know, I spent a lot of time in quality before I moved over to real world research. And so I'm passionate about being able to use data to help people improve their quality scores. If people are getting, you know, urinary tract infections from catheters not being changed, I want to be able to find that that happened and count the number of times it happened and then ask really good research questions. And that's actually what pushed me more into the research side, was what was going on. Were people understaffed? Were people, like, what was happening that we had this event happen for a patient that we want to make sure isn't happening, you know? And
Right.
so being able to ask those questions out of medical records is so vitally important. It makes us all safer, it makes healthcare better, it improves it. But holy cow, it's hard. It's so hard to, like, pull that information together out of healthcare records. Um, Sorry, John, you got me off onto a tangent and a passion.
Yeah, no, it is hard. And imagine a neural net trying to piece together uh, a as a clinical uh, conclusion from the disparate billing and EMR data, you know, when it's so hard to show that from a research perspective, right?
Right.
When you know there's a negative outcome, but you're trying to sleuth out why that negative outcome occurred. That, you know, the I mean, good luck trying to. How many billions of dollars are you going to spend trying to train a neural net to become, you know, Sherlock Holmes and sleuth out the cause of a negative outcome, right? That is that's just a very poor use of money, you know,
Right.
when when we should be funding actual healthcare, right? Rather than trying to. I'm all for spending money on AI if it saves money
Right.
on staff, on actual effort and labor, but trying to reduce the research aspect that humans are doing down to a neural net is an impossible task. I mean, if you could accomplish it, it would be so expensive to create that capacity that it doesn't seem like a good use of. You could probably pay for everybody's health care for a decade for the amount of money you'd have to spend building that kind of a neural net capacity.
Yeah, which, goes back to where we started. Like, let's pretend that you and I got called into the business and, somebody in some department has this kind of like, hey, let's try this. Can we just make it easier that researchers can say, I need a data set on patients who have these characteristics, and I want to look at whether or not that increases the rate of a urinary tract infection from a catheter. I want to pull these variables, and then I want to look at, was the incident rate going down for certain populations? Was it going up for other populations? Like, what's driving these events to happen? I don't know, given, and I don't want to call it vulgarity, but just, I don't know that an electronic medical record system is designed to support that.
No, it's
I
not.
think,
and
that it needs to get abstracted first. Like,
yeah. I mean, common data models are, that is going to be the most expedited way to formulate those questions and get results that are reasonably valid. Like, you could then start your research from that point. But that's building off of years of people curating the data to build those data warehouses, right? You're leveraging decades of effort.
Yeah, decades of people saying, how do we know if a patient dies? How do we know if this happens? How do we, and then having to go at, their institution and vetting through like all the crazy in the data. Actually, it's funny, John, I told you there were two things and we only talked about one, which is the diversity of workflows and how people record things. The other one I have a hard time believing is only a healthcare problem. There has to be other places that have this problem. But hijacking your application, I mean, I know we had an organization that had mobile health units. It was like an outpatient clinic on wheels, big, think like truck. And they could pull to different places and do healthcare for people, whatever. And the big system, there was no facility type called mobile healthcare. And in fact, National was having a very hard time calling that a facility because it didn't fit their governance definition of what a facility is, right? So they were like, well, we don't think that's a facility. And they're trying to get the EMR rolled out to this organization. And the organization's like, well, the only way we can schedule appointments and have healthcare encounters with people in this EMR system is that we have to put what facility we're scheduling them at.
Right.
Which means our mobile health van is a facility. That's the only way it works in the system. Because encounters are tied to facilities. And you can't enter a facility unless you have a facility type. So all we need is to add one code to the facility type dropdown that says mobile health van. That's all we need. Please do that. Otherwise, we can't start using the EMR. Okay.
Yeah.
And National is caught up in this whole well, we don't think a mobile health van is a facility. It doesn't fit our governance definition of what a facility is. And it was this horrid thing. But that organization had no hospitals. Right?
Right.
So after fighting all the, corporate foolishness of large scale EMR rollouts, that organization said, forget it. We'll just pick hospital for the facility type because we don't have any hospitals. We know we're talking about mobile health vans. Right?
Right.
So they go and hijack the system and just use a code that they didn't need for something else.
Right. Yeah.
And this
no,
was,
and
this
that
was
absolutely happens all the time. I mean,
yeah,
in
and
every kind of system.
Yeah, this was absolutely fine until flu season hit. And National is monitoring the number of people who show up in hospitals with flu-like symptoms. And suddenly our reports explode for that one area of people who are showing up with the flu at a hospital.
Right.
Because that's a pandemic indicator that you suddenly have an onslaught. Right, data was wrong. Data was wrong. But that's the other thing about just pointing. The AI can figure it out. Like, nobody could figure that out. You, literally would have to go, the data is saying A, but we know that that's not happening.
Right.
Right?
Yeah, no, and you have to be really careful how you structure incentives with data entry. If you have key metrics tied to somebody's performance review or whatever, those kinds of incentives can just totally change the way they utilize the applications that are monitoring their behavior, or even change their behavior in ways that you didn't expect.
Tell me how I'm measured and I'll tell you how I behave.
Yeah.
Right.
Yeah. So, yeah, and that is, and I think probably we will see an explosion of that as we have more AI generated applications where it's not going to kind of innately think about how would this affect me if I had this application, how would it change the way I operate? If people are young junior developers are using, Copilot or what have you to generate lots of code for their applications, those applications may function just fine, in terms of, but does it have a business impact that, the people developing it didn't think through because they're producing, the code so quickly they don't have time to consider
to consider the rollout plans.
Yeah.
And the same depth as when coding was slower, that could be developed hand in hand.
Right.
Versus we have a system. Okay, roll it out. I think about our go lives. Early in my career, we had blue shirts and we had the red shirt folks, and we'd have people out on the floors, and we'd roll a new IT system out, and there were people who were there to assist to make sure that people were using it correctly, and that all this, and that's disappeared over my career. We don't have blue shirt folks that are on the floor, and those sorts of things. I'm sure there's still facilities that are like that, we're rolling out this new system, and we're going to make sure we have folks on the floor, but that used to be incredibly common, and it's kind of disappearing these days.
Yeah, I think the mantra "move fast and break things" that has, I would call it obsessed software development, and agile development and different methodologies that kind of uh, whether intentional or not, uh, promote that mentality, away from the days of software engineering and waterfall methodologies, which were much more planned and carefully uh, instituted into our systems. Um, the I definitely think we're going to see issues increasing in terms of quality issues that have significant financial and even human life impact as we accelerate even more with um, inordinate amounts of generated code. Um, I find my productivity is significantly higher using Copilot than when I hand code. And so I use it all the time now. Because it's I basically can write large amounts of code in any language, and then I'm just kind of working my way through the algorithmic aspects of it to make sure that it's functioning. But yeah, do I give it as much thought as I would when I'm coding every case statement, every loop, every variable? No, I don't. I just, a ton of code gets generated, and sometimes I'll be like, well, that's not a very good variable name, and I'll modify the variable name, but it's just so much faster, and I can be so much more productive.
Do you use Copilot to generate test cases?
Oh yeah, yeah. You can tell it, uh, you know, uh, I do test driven development, so I'll have it write my test cases first, and I'll tell it, give me a test case for this. Here's my input. This is the output I want. Write a test case for it, and it'll generate a test case if I want it in Python or if I want it in Java, whatever.
That is definitely my preference. I've been in a position that I've kind of inherited tons of code that other people have written that don't really have the test cases with them, and then I'm having to kind of work through that process of like, okay, how do I restructure this so that it actually is more object oriented, and then also once I figured out like, okay, I can tell you over this 10,000 blocks that this is the input and this is the output, but that's nowhere near the level that you want to do your unit testing on. So now I've got to break it down and start getting this organized. Going the opposite direction, I have found a little bit hard in terms of getting it structured and getting good test cases with it. But
Yeah, Copilot.
having AI just generate your like, okay, this function is generally doing this. Give me a test case with these kind of inputs and outputs. Definitely is a huge time saver.
I've had now different neural nets, different large language models produce code very differently.
Mm-hmm.
Copilot's nice because I'll give it the description of what I want and get some code, and then I'll finesse it. But it's not related, right? So if I fed into ChatGPT a test case and I said, "Oh, write me some Python code that passes this test case," it'll frequently generate code where it's basically a trivial case, right? It's not writing generic code. It's writing code specifically that just takes the input of the test case and generates the output of the test case. It'll do weird things like that.
Oh,
I
that's
don't use
interesting.
ChatGPT or any of the other large language models generally for code production. I just use Copilot, GitHub Copilot, not Microsoft Copilot, although Microsoft now owns GitHub. But those are two different products.
Holy cow, that could be a whole other hour of us talking about.
Yeah.
All that overlap.
Yeah, I mean, I think we're going to end up with having machine learning and having neural nets, trained neural nets being used in every aspect of our day-to-day lives and jobs, but that they're going to evolve much along specialized lines more and more as that we're going to find that people will be taking trained models and customizing them for very specialized use cases. And that's why I don't like using the term artificial intelligence, AI, because I'm just like, it's just adds a layer of, fairy dust onto everything that, is actually just an engineering problem. And and leaves people who are managers, trying to manage, or project managers, or are product managers, leaves them thinking that that somehow their developers are going to just be able to enter some prompts and suddenly have a working product. And I think the healthcare data problem is a good allegory for the limitations. Allegory is maybe a metaphor, I don't know, but it's a good use case for illustrating the limitations of your large language model,
where we are today.
Nets.
Yeah, of where we are today.
I honestly, I think we are maxing out.
Ooh.
It's not that we are not going to see a ton more improvements and development, but I think we are maxing out what we can feasibly do with our given hardware and financial capabilities.
And power
so
grid. There's also those considerations.
Yeah. Yeah. That is when Microsoft is buying up old 3 Mile Island to try to fire up 3 Mile Island in order to provide power for a data center, you're pushing the limits of what we can financially accomplish.
Right. When you're like, that's now economically viable. Holy cow, we're straining on the edges now.
Yeah.
Right. I know I asked you for an hour of your time, and I want to be respectful. We're already starting to go over that hour. And the funny thing is, John, is where we went is not where I expected. Because when I said let's just take this like a business owner approaches us, and I had kind of thought, maybe we get off into I guess we kind of did start to talk about the difference between model-centric AI versus data-centric AI, because we started talking about like the fact that healthcare data, we'd be far closer to solving this problem once the data is in a curated form rather than it's in the wild form. So I guess we did kind of start the difference between model-centric AI and data-centric AI, but I almost expected you and I to talk about, that moment where the business thinks whatever latest buzzword is going to be the silver bullet that solves everything, and why can't you guys just do it? Everybody else does it,
Right.
kind of stuff. You and I both have war stories. And then the other place I thought we might end up going is because we're both mathematicians by training and background and interest. I'm more on the stats side. And so, I had thought maybe we might geek out around some of the family-wise error rates when you're talking about having to make that many leaps of logic to go from this incredibly messy biology and rationalize it, that every step in that rationalization process you're adding error and noise to the system. And I don't know, like there's a ton of topics that I thought if I threw this out that we might end up going down the rabbit hole, but I actually like the rabbit hole we went down.
Yeah.
Just talking about why healthcare data is so different from other types of data that's out there. I think one of the things that the AI space is changing is that people are moving away from like enterprise curated data sets to having to deal with the same types of vulgarity that we've, for decades had to deal with in healthcare. And I think there's a lot of things coming out on the market, that are designed to deal with this kind of problem where it's like, oh, this is a whole new thing. The organization didn't have their clerk type in the value so that I could put it into my data engineering thing with this beautiful data and then stick it and make, beautiful enterprise reports happen. I'm now scraping web pages and scraping documents and I've got data entry problems and vulgarities of data going on that are adding vulgarities of data.
It is ironic, and I think we've touched on why this is the case, but it is ironic that we have neural nets that can fold proteins, but we don't have a neural net that you can ask, hey, how many people got this procedure? That we don't have a neural net that can do that, right?
Not yet.
Yeah, and my guess is that when we do get it, it's going to be providing some radically wrong numbers when it does that, right?
Right.
And so unless it's working with a very curated data set and is trained with a highly already managed data set, where those numbers are already being produced and it's doing something trivial like, oh, let me go look this up in a set of counters that have been heavily curated and managed.
Yeah, which is like 100 other AI projects that healthcare probably should use to help them get to the point of having the curated data set before we could have, an ontology that sits, that's trained in AI systems so that we can write SQL queries.
Right.
Right?
Yeah, after
it goes back to the problem. They're asking for something that's like 1,000 projects.
Right.
To get to the point that you can deploy the silver bullet that fixes it all.
Yeah. It is a danger that we will do all the data curation and effort and lift, and then somebody will deploy an AI that does nothing but query the curated data, and somebody will go, oh, you've got an AI that has solved all my problems. We don't need all those data people. That actually the AI is just doing nothing but generating a simple select star from table that is curated.
Right.
right? And suddenly they've got, and then 2 years later, they're like, why is this data not getting updated?
Why doesn't it work anymore?
It's giving me the same answer that it gave me 6 months ago. What's
Right.
going on?
Right.
Oh, all those people you let go actually were doing work behind the scenes to make the
AI look pretty.
the Wizard of Oz, give you the give you the fancy result that you were expecting. So
Wow,
yeah,
that's a neat analogy. I do sometimes feel like the wizard behind the curtain.
yeah.
Yeah.
The danger is that people think the projection is the they don't realize all the work that happens behind the scenes, right?
Right.
And so they don't value the effort that goes into making something simple and easy to use.
Yep. Which I think I'm going to close on that same thought, because that's what motivated me to start trying to do this, get together and have conversations about data and being in the data world and the challenges. And John, I am so grateful that our careers crossed paths, even though it was a very short period of time before we moved on to other jobs, but that we've kept in touch with each other.
Yeah.
I would love to have more conversation, even just sticking with this whole premise of please get me the silver bullet AI wizard projection on the wall. And I don't see how many people have to be behind the curtain. Let's get together again and keep talking, because I think there's tons of other things that we actually just didn't get into that I'd love to discuss in depth with you about living in that data world,
Yeah. Sounds good.
All right. Have a great evening.
Yeah, you too.
All right. Catch you later.